Good day to everyone. This is Greg Enriquez, the President and CEO of Dyna Industrial Corporation, the company that has been in existence for the last 30 to 40 years. We represent a company in Europe and America and Sweden. The needs of the time, especially these days of high costs of fuels. Did you know that 7% of building electric costs is air conditioning? Up to 20% savings can be achieved through what we call DryCool technology. Here is more or less a comparative description. DryCool units are like fuel additives. While we have methanol, gasoline for fuels, we have also additives for buildings, commercial, industrial applications that saves energy once it is in tandem with the existing air conditioning. What it does is simply minimize air conditioning energy operating costs. As I've said, it's like a fuel additive. It lessens the pure fuel, which is expensive. In DynaCool technology, it lessens the use of central air conditioning because it has acted in a way where it will reduce air conditioning loads. Here's the basics and facts about DynaCool or DryCool technology. You have seen 3 to 0.5% of the gross national product of a country is lost due to high humidity or corrosion attacks on metals. Here, as you can see, sweating buckets blame high humidity. High humidity is not good for human comfort, and it's not good too for air conditioning because it is an added bigger loads of the components, two components of a ton of refrigeration: sensible and latent load. The latent load is the humidity or moisture in the confined space. Here's the comparative in terms of costs. On the left side, it's conventional air conditioning. Using 1000 CFM, it will require 7.5, whereas in DryCool technology, it will only be about 5 kilowatt. Here are some applications of it. It is best for pharma, laboratories, food industries, semicon. As usual, the bad effects caused by high humidity are rust and moisture, oxidation, short circuit on microchips, bacterial growth, spoilage, mold attacks, short shelf life, production downtime, deteriorated packaging, mites attacks, rotten boxes, discoloration, wet products. In short, they do damage materials, parts, and even finished products. However, if a confined space is subjected to good temperature and humidity control, here are the benefits: high quality, longer shelf life, high medical efficacy, fresh and retain good color, minimize rejects, minimize what you call the 6 building syndrome due to bacterial growth when humidity is high. And the rest are what you can read in there. Here is a paper where DryCool technology is better than conventional air conditioning. It has a saving of 1.1 million additional cost. Then you divide the additional cost over the savings. You divide the savings over the investment cost, you'll get the ROI. It shows there. Munters, dehumidifier, Fox, and Basic. As I've said before, 7% of building, commercial, industrial, electricity is air conditioning. This is the energy pie. It shows 70% of air conditioning as the load of a building. The rest are 5 to 10% lightings and other equipment. However, still, the basic and majority of the load of the building is air conditioning. Yes, the problem is really moisture, as you can see. It affects a lot of products. People should have its comfort zone to be very comfortable and productive. That's what ASRE says. Hazardous microbiological growth, where molds, bacteria, and other microorganisms, as a result of uncontrolled humidity, thrives in surfaces, items, products. DryCool, as you can see, saves electricity. The other benefits: improves air quality, which is now the common problem of human beings because of pollution, too many particulate count in the room. So it boils down to health when room is not properly controlled in terms of temperature and humidity. Here is a unit of DryCool. The internal parts are simply the DX coil, the rotor, which is the absorber, the condenser, which its waste heat is regenerated to put back the desiccant rotor to its original and absorption capability. Yes, that's right. 40% more or less can be saved out of use of efficient technology. Here is a picture of what happens to products. In pharmaceutical, you can see rotting medicines, caking, packaging, it's crumpled. The product is not efficient.